Okay, so let's do another question, question number 5. So in this question, let's read out the question just to get a feel for it. So in this question, we're given the time, capital T minutes taken by people to compare a test has probability density function given by ft equals to k bracket 10t minus t squared for a domain where time is 5 to 10 and 0 otherwise, where k is a constant. And the first question is just simply asking us to show that k equals to 3 over 250. Second question is just asking us to find the expectation value of the time. And the third question is basically asking us to find the probability that a randomly chosen values of t lies between expectation of time and the median of the time value. And of course, in the fourth question, we're asked to find the greatest possible length of time taken to complete the test. Okay, so the solution is pretty straightforward here. In that first question, we simply use the definition that the integration of a probability density function sum over the limits gives you the value to be 1, right? So that's the first definition we use here, but instead of x there's t here, right? And you're also given the limits from 5 to 10 here. So this is 5 and then 10. Okay? Now, if you substitute ft as the question given here, ft is this, right? So if you substitute this out here, because this is the boundary here, right? This is the limit for this function, so 5 to 10, integration of ft dt equals to 1. We don't take this because 0 multiplied by any variable is 0, so the probability is 0 otherwise. So after you integrate, you get this value here, this expression here, and then you substitute the you substitute the limits here in this integration, and then you get this one simplified to give this one. Okay? And in the second question, you're simply asked to find the mean. So expectation of time basically means 5 to 10, integration from 5 to 10, and then t ft dt. Again, it's the definition. You want to find the expectation value. You multiply it by x, fx dx. So fx is already here. If you multiply by x, you get the mean. Okay? And then similarly, you simplify it. Okay? Simplify it to get this expression here. Now, I want you all to do the simplification process line by line, because you might not be getting the same answer, and then you might not understand what's going on here. Okay, so after simplification, what you get basically is 6.88 minutes. And that's the mean time. And question number 3. Now this is interesting bits of this question, because we have to find a probability that a randomly chosen value of t lies between the expectation value and the median of the time t. Now obviously the first problem is we don't know the median, right? So what's the median of the time given that probability function? So what we do is we'll just suppose m to be the median. Again, by definition, the median the median m is given by integrating the lower limit to to the upper limit is a median. You integrate over the probability density function with respect to dt, and the area is half. So this is the definition of the median. So if you want to write the definition properly, you basically write something like this. Integration. So you're integrating from minus infinity to certain value of median. Okay. And you're integrating a function fx dx, and this area has to be equals to 1/2. So this is the definition here. Now you might be wondering here, there's minus infinity here and this is 5. As we saw in the previous, from the question we're given that the function is valid from 5 to 10, right? So the median has to be from 5 to 10. So the lower limit is 5 here, so we put 5. And then again, it's just a matter of simplifying. You simplify the expressions. You simplify the expressions like this, okay, integrated. And this is the important part here now. Okay, so you are finally, when you see the expression, you get cubic function here. Now, if you use a calculator, you can find the value of m to be 6.74 or minus 4.39 or 12.66. Okay, now the only valid value of m is 6.74 because our domain's lower value is 5 and the maximum value is 10. So the only value that lies between 5 to 10 is this. So this has to be the median, right? And then after that, what do? You simply find the probability, right? So probability from the median to the expectation value of ft dt is simply this. Now notice here that the expectation value is up and the median value is lower. So it means the the value of median is lower than the expectation value here. So when you integrate this one, you get 0.0365, and that's correct. So the fourth question simply says state the greatest possible length of time to complete the test. So in this case, you could just go up with the value of t equals to 10, because our domain here goes from 5 to 10. Okay, so that's it for today. So I will see you on the next question. So let's move on to question number 6 now.